Hi everyone, in this video I will discuss about coordinate geometry. Coordinate geometry is one topic about coordinates, lines, gradient, the relationship between two lines, there are parallel lines or perpendicular lines, and also we will see about the distance between two coordinates, distance between one point to a line. And then, of course, we will see about circles. Find the equation of the circles, the relationship between a point and a circle, and the intersection point of the relationship between the circle and the line. So, check this video out. Let us start with the first discussion. It's about distance between two points. As we know that the coordinate geometry is a topic related to the coordinate in a Cartesian diagram. So Cartesian diagram is the diagram of xy, in two dimensions. If we have two coordinates, coordinates A and coordinates B, and we want to find the distance between the 2 points, we can find the distance between 2 points by first construct the right angle triangle. This, so we can find the length of AB as the hypotenuse of the triangle. The height of the triangle is the change of y coordinates. Of course, the coordinates of A is x1 and y1, and coordinates of B is x2 and y2. So the height of the triangle is the delta y, or we can say y2 minus y1. While the change of x, the base of the triangle is the change of x, which is x2 minus x1. Therefore, the length of the hypotenuse of the triangle will be taken by using the Pythagorean theorem. So the square root of delta x squared plus delta y squared, where delta x is x2 minus x1, and delta y is y2 minus y1. So this is the formula for the distance between 2 points. I will take one example from question number 1. Find the distance between coordinate A and coordinate B. So the distance between AB is the Pythagoras of delta x. Delta x is x2 minus x1. I will take this x2 and 2 as the x1. So it's -1, -2 square plus delta y. Delta y, so this is the y2 and this is y1. 7 minus 3 square. So this is equals to square root of -3 square plus 4 square, which is equals to square root of 25 equals to 5. So that means the distance A to B is equals to 5. This is the first one. You can try all the questions here as your practice. Find the distance between 2 points. We use the Pythagorean theorem. Find delta x and delta y, and then use the Pythagorean theorem to find the length between 2 points. Let us move on. Next, midpoint. Midpoint is the coordinate in the middle of 2 points. So for example, I have this Cartesian diagram, xy. This is coordinate A, x1, y1, and this is coordinate B, x2, y2. The midpoint is the coordinate M, which is the midpoint. So I can say this is x and y. Now, to find the midpoint, we can sum the coordinates and then divide it by 2. So sum the x coordinates, x1 plus x2 divided by 2, and the y coordinates, y1 plus y2 divided by 2. Example, I choose number 2. So the midpoint of A and B is, the x is 4 plus 2. Taken from here, x1 and x2 divided by 2. And then the y is negative 2 and 5. Negative 2 plus 5 divided by 2. So equals to 3, 3 over 2. So 3, 3 over 2 is the midpoint. Now you have to pay attention about the sign here. In midpoint, we sum the coordinates, while in distance, we subtract the coordinates. Yeah, don't get confused. Next, gradient of the line. Gradient, or sometimes we call it as slope, is the ratio between delta y and delta x. So the gradient or the slope is rise, delta y is rise, over run. Delta x is run. So this is rise and this is run. So gradient is equals to rise over run. So delta y again is y2 minus y1, and delta x is x2 minus x1. Example again. So I can try number 2. Find the gradient of A and B. So the gradient, the symbol is M. MAB is delta y. Delta y is negative 2 and 5. So I will do 5 minus negative 2 over delta x. Delta x is 2 and 4. So 2 minus 4 equals to 7 over negative 2. So equals to negative 7 over 2. So this is the gradient of the line. Now, the sign of the gradient, if negative, that means the line is going to the bottom right. This is negative gradient, if the gradient less than 0. But if the gradient is positive, the line is going to the top right. Yeah, negative gradient is going to the bottom right. The positive gradient is going to the top right. Next is equation of the line. We have general form or general rule of the equation of the line. The general rule is y equals to mx plus c. While m is the gradient of the line, c is the y-intercept. Yeah, so if I have again the Cartesian coordinates, this is the line. The line is y equals to mx plus c. If we put x as 0, so we have y equals to c. So that's why this is c. That's why c called as the y-intercept. Now, how do we find c? Equation of the line is the function that satisfies all coordinates that the line passes through. So all coordinates, all points that satisfy the equation should be on the line. That means we can just use any point that the line passes through to find the C. For example, number 1, find the equation of the line m equals to 2 that pass through point A 3, negative 5. So according to the general rule, the equation is y equals to mx plus c. The gradient is 2x plus c. So this is the general formula. We have to find the value of c. Now, because the line is passing through the point A, that means the coordinate A will satisfy the equation. So we can just replace the value of A. Y is negative 5. 2 times x is 3 plus c. So we have negative 5 equals to 6 plus c. So c equals to negative 11. So the equation for number 1 is y equals to 2x minus 11. So all the coordinates that satisfy this equation will lie on the line. So you can use any coordinates, any points on the line to find the constancy. Another example, I will take number 4. Number 4, we don't know the gradient. So we have to find the gradient first. Number 4, I can rewrite here. So find the gradient of AB first. The gradient of AB is delta y, negative 1 and 4, negative 1 minus 4, over delta x, 3 and negative 2. So 3 minus negative 2. So equals to negative 5 over 5 equals to negative 1. So the general rule is y equals to mx plus c. So the m is negative 1, x plus c. And then the line is passing through the point A and B. Because A and B, I draw the line passing through A and B. Because A and B are on the line. So both A and B will satisfy this equation. So we can just replace either A or B to find the value of C. I will choose A. So the y value of A, I will choose coordinate A. The y value of A is 4 equals to negative 1 times x. The value of x is negative 2 plus c. So 4 equals to 2 plus c. So c equals to 2. So that means the equation is y equals to negative x. Negative 1x is equals to negative x plus 2. Now, check with coordinate b. Is b on the line AB? B is 3, negative 1. So I put 3 in the equation. So it's negative 3 plus 2 equals to negative 1. So correct. So that means A and B are on the line with equation negative x plus 2. These four are the basic concept for coordinate geometry for this topic. The next subtopics will be based on these four subtopics. So let's see the next one, parallel and perpendicular lines. Parallel lines. This is parallel lines. They have the same gradient. But perpendicular lines, they are perpendicular if M1, the first gradient, and the second gradient multiplied equals to -1. Or just simply, the second line is equals to -1 over the gradient of the first one. Okay, let's see example. I will choose A. Find the gradient of the line parallel to the line y equals to 5x plus 5. Now, we can see that this equation is following the general form. Y equals to mx plus c. From this equation, we can say that the gradient of the line is equals to 5. The gradient of the line parallel to this line is the same gradient, so equals to 5. Next example, I will choose D. 2x minus 5y equals to 4. We have to find the gradient. To find the gradient of this equation, you have to change this into the general form. So it's -5y equals to 4 minus 2x, while y equals to -5 minus 2 over -5x. Or I can simplify into -4 over 5 plus 2 over 5x. Now this is c plus mx. So the gradient is the coefficient in front of x, the coefficient of x. So the gradient here is 2 over 5. So the gradient of the line parallel to this line is equal to 2 over 5. Now number 2. I will choose A. Find the gradient of the line perpendicular to this line. According to the rule, the gradient of this line is -3, the coefficient of x. So that means the gradient, the line perpendicular to this line is equals to -1 over m1. So -1 over -3 equals to 3. Again, C, we have to change into the general form. So 6y equals to 9 minus 3x. So y equals to 9 over 6 minus 3 over 6x. Or we can simplify 3 over 2. Y equals to 3 over 2 minus 1 over 2x. So the gradient of this line is equals to -1 over 2x, -1 over 2. And the gradient of the line perpendicular to this line is equals to -1 over -1 over 2, which is equals to 2. That's the example. You can try the other number as your practice. I will move on to the next subtopic, intersection points. So we already learned about find the distance between 2 points, find the midpoint, find the gradient of the line, determine the equation of the line, find the relationship between two lines, parallel or perpendicular. And now we can find the intersection between two lines. Of course, they are not parallel. If they are parallel, there is no intersection. So if they are not parallel, they will have one intersection point. Now, the one that you have to remember is at the intersection point, the y coordinates the same. The x coordinate also the same, but we can use y1 equals to y2. So we can make the y the same, or just you find the simultaneous equation. Yeah, for example, like this. This is the intersection point. So this is the point where the y of the first line is equal to the line of the second, to the y of the second line. For example, find the intersection points between the lines A and that one. So I can make it the same. The y1 is 2x minus 1 equals to the y2 for x plus 5. And then I can just simplify. It's negative 2x equals to 6. So x equals to negative 3. While y equals to, we can just replace the first one, for example, 2 times negative 3 minus 1 equals to negative 7. So the coordinates of intersection is negative 3 and negative 7. That's for A. How about B? For B, I can just do the simultaneous equation. So 2x minus 3y minus 4 equals to 0. And then the second one is x plus 2y plus 5 equals to 0. So to do the simultaneous equation, I have to remove one variable because we have x and y, two variables. So I have to remove one of them. In this case, it will be easier if I remove x. So we have 2x here, we have x here. So I have to multiply the second equation by 2. So I have 2x minus 3y minus 4 equals to 0 from the first equation. And for the second equation, we multiply by 2, become 2x plus 4y. Yeah, multiplied all terms by 2. Plus 10 equals to 0. And then to remove the 2x, I just need to deduct. So I deduct. So this one will be eliminated. And then negative 3y minus 4y is negative 7y. And then negative 4 minus 10 is negative 14 equals to 0. So negative 7y equals to 14, y equals to negative 2. X equals to, just put into one of them. Yeah? You can put in the second equation. So x plus 2 times negative 2 plus 5 equals to 0. So what's the result? X will be equals to x minus 4 plus 5 equals to 0. So x equals to negative 1. Yeah, that's it. So you can try the other numbers for your own practice. For miscellaneous questions, I leave it for you for your own practice as well. Okay, we move on to circle. Equation of a circle. We have two types of equation according to the center of the circle. Equation of the circle, for example, the center is origin, and I have any coordinates k, the coordinates are x and y. So the equation of the circle, equation means the position of the coordinates that lie on the circle. So we know that circle has radius, and this radius will equal in all directions. This is negative x comma y, this is negative x comma negative y, this is x comma negative y. So the position or the equation of the circle is equals to the Pythagorean theorem. So it's x squared plus y squared equals to r squared. So this is the equation of the circle. That means it will indicate the position of any coordinates, any points that lies on the circle. Now, how if the coordinate is not at the origin? It's at coordinate A, comma B. So the same thing, this is R, and this is the coordinate x, comma y. So now we are using the Pythagorean theorem as well. So the delta y here is equals to y minus b from here. This is y and this is b. So y minus b, delta y. And also for x, from here to here is x, and from here to here is a. So delta x here equals to x minus a. So the Pythagorean theorem here is x minus a squared plus y minus b squared equals to r squared. So these two are the equation of the circles according to the center O and center A, comma B. And if we expand this equation, it will be expanded into this one. Now, how if we have this equation and we want to find the center and the radius of the circle? We know that the equation of the circle has the information of center and radius. So the center is A, comma B. It's coming from here. So the center is, I can call this as A and this as capital B. So the center is A divided by -2 and B divided by -2. And to find this radius, I can call all of this as C. So C is equals to A squared plus B squared minus R squared. That means R squared is A squared plus B squared minus C. We will use this in the example after this. Okay, let's start with the easy one. Exercise number 1. Find the equation of the circle, center at O, radius 5. So we can just use the formula x squared plus y squared equals to 5 squared. Or x squared plus y squared equals to 25. Next, B, center 3, 4, radius 5. So B is x minus 3. Yeah, this is A. And this is B squared plus y minus 4 squared equals to 5 squared. You can express your answer in this form, or you can expand this when needed. Okay, you can try other numbers for your own practice. Number 2, determine the coordinate of the center. Now, we need to use the formula that we have before. The center is like A over -2, B comma negative over -2, and the radius is A squared plus B squared, which is the center here. A and B here are the center. So for example, to A, x squared plus y squared equals to 30. The center is 0, 0. Another example, I will choose D. X squared plus y squared minus 10x plus 4y minus 30 equals to 0. So if we see from the equation we have before, A is the coefficient of x and B is the coefficient of y. So that means we have A and B. So the center is A -10 over -2 and 4 over -2 equals to 5 -2. That's the example. Number 3. Okay, number 2 and number 3 are the same numbers, but different question. Determine the radius. This is not coordinates here. Determine the radius. So from the first example, x squared plus y squared equals to 30. So we know that this is r squared. So r squared equals to 30. So r equals to square root of 30. In this case, we don't put plus minus because the radius has only positive values. And then D, we know that the center is 5, -2. So how do we find the radius? The formula is radius square equals to A square plus B square minus C. So A and B in here is the center. So this is A and this is B. So this is 5 square plus negative 2 square minus C. C is this one. You can see here, the C is all the numbers with the coefficient. A square plus B square minus R square. So the C here is the number only, the constant. So in this case, C is negative 30. So equals to 25 plus 4 plus 30 equals to 59. So that means the radius is square root of 59. Next, perpendicular distance. The shortest distance from a point to a line is a perpendicular distance, calculated by the formula. This one, we can use the special formula. Yeah? So if you have any point and you want to find the distance between the point to any lines, so the shortest distance is the perpendicular distance because it make angle 90 degree. So you can put into the formula. So ax plus by plus c over square root of a square plus b square, the Pythagoras of the coefficient of the line equation. And then replace x and y with the coordinates that you want to find the distance from the line. For example, okay, in the diagram, the line is a tangent to the circle C. Find the equation of the circle. Now, to find the equation of the circle, we need center and radius. Okay, from the figure, we know that the center is 0, 0. So center equals to 0, 0. And the radius, we can find the distance between 0, 0 to the tangent line. So that means we can use this formula. The radius is the perpendicular distance from 0, 0. So the line equation is 3x plus y minus 10. We put the absolute value, that means the result will be always positive. Square root divided by square root of 3 square plus 1 square. It's taken from the coefficient of x and y. So we replace the 0, 0 here, the coordinates. So 3, 0 plus 0 minus 10 over square root of 3 square plus 1 square. So equals to negative 10 over square root of 10. So this is square root of 10. This is the radius. So the equation is x squared plus y squared equals to r squared. So x squared plus y squared equals to 10. Number 2. The line L is a tangent to the circle centered at 2, negative 1. Find the equation of the circle. So this is the center. So if we draw, this is 2, negative 1. And this is the radius perpendicular. And this is 3x minus 4y equals to 20. So we can find the radius using the formula again, 3x minus 4y minus 20. So we have to make it in this form. Square root of the Pythagoras, 3 square plus 4 square. So we replace the coordinates. So 3 times 2 minus 4 times -1 minus 20 over square root of 25. So 6 plus 4, so it's -10. Absolute, so it's 2. So the equation is, the center is 2, -1, so it's x minus 2 square plus y plus 1 square equals to 2 square. X minus 2 square plus y plus 1 square equals to 4. You can try the exercise for your own practice. Point on the circle. Now we can check the position of the point according to the circle. So we can find 3 types. The first one, the point is inside the circle. The second one, the point is on the circle. And the third one, the point is outside the circle. How do we determine the position of the point? We can find by compare the distance from the center to the point. If it's less than the radius, the point is inside the circle. If it's equal to the radius, the point is on the circle. And if the distance from the center to the point is greater than the radius, that means the point is outside the circle. That's the first point, the first method. The other method is by substituting the point to the equation of the circle and then find these conditions. If the value is smaller than 0 or negative, it's inside the circle. Is equals to 0, the point is on the circle, and if greater than 0, the point is outside the circle. Example, using the second method here. Determine whether the points are inside, on, or outside of the circle. Okay, so we can check -3, -2 to the equation. -3 square plus -2 square minus 2 times -3 plus 8 times -2 minus 8 equals to 9 plus 4 plus 6 minus 16 minus 8 equals to 13 plus 6, 19, 19 minus 16, 3, 3 minus 8 is -11. So this is smaller than 0. So that means this is inside. The second one, 5 -1. So it's 5 square plus -1 square minus 2 times 5 plus 8 times -1 minus 8 equals to 25 plus 1 minus 10 minus 8 minus 8. So equals to 26 minus 26 equals to 0. So this is on the circle. And the last one, -2, 1. So -2 square plus 1 square minus 2 times -2 plus 8 times 1 minus 8 equals to 4 plus 1 plus 4 plus 8 minus 8 equals to 5 plus 4 is 9. So it's greater than 0. So this is outside. So we can check the position using the equation of the circle. replace the coordinates to the equation of the circle, and then find these conditions. If the value is greater than 0, it's outside the circle, equals to 0 is on the circle, and less than 0 is inside the circle. A circle with center -1, 3 pass through the point 1, -1. Find the equation of the circle. So the circle center -1, 3 pass the point 1, -1. So again, to find the equation, we need center. The center is -1, 3 and the radius. So we can find the distance between 2 points. So using the Pythagoras theorem, so delta x squared plus delta y squared. So 1 minus -1 squared plus -1 minus 3 squared. Square root of 2 squared plus 4 squared equals to square root of 20. So the equation of the circle is x plus 1 squared plus y minus 3 squared equals to r squared. Square root of 20 squared. So x plus 1 squared plus y minus 3 squared equals to 20. Three, the point are two ends of the diameter of a circle of the center 0, 0. Find the radius of the circle in subform, and then hence find the equation of the circle. So radius, we just need to find the equation, the distance between 2 points. Again, using the Pythagorean theorem. So it's it's 3 minus 0 square. I just pick this and this here, the center here, and then -1 minus 0 square. So equals to square root of 3 square plus 1 square, square root of 10. Hence finds the equation of the circle. So the center is 0, 0, so it's x squared plus y squared equals to r squared. X squared plus y squared equals to 10. 4. Find the equation of the circle with center containing the point. So contain the point 1, 1. That means it's on the circle. So this is circle, this is the center, -2, 4, and this is the coordinate 1, 1. So find the radius again. Pythagorean theorem. So 1 minus -2 square plus 1 minus 4 square. It's 3 square plus 3 square. Yeah, this is -3, the same with 3 square. It's square root of 18. So the equation is x plus 2 square plus y minus 4 square equals to 18. I leave the exercise for your own practice. intersection between a line and a circle. In determining the points of intersections between the circles whose equation of that and the straight line y equals to mx plus c, we can have three possible cases. The first one, they will cut in two distinct points. Second one, they will touch, or we call it as a tangent, or they have no intersection point. Now, to know these conditions, we can ask help of the discriminant. Yeah, remember the discriminant in quadratic equations topic. So to obtain the points of intersection, if they exist, first we have to solve the two equations simultaneously. So we make the y, we replace the y of the equation of the straight line to the y of the equation of the circle simultaneously, yeah? And then we can simplify the expressions. After that, we can determine the number of solutions. If there are two distinct roots, so they have two intersection points. If they have only one root, so it's a tangent. And if there is no real root, that means the discriminant is smaller than 0. If the case is number 2, so you just need to solve the quadratic equation. Example, equation of the circle is x squared plus y squared equals plus 4x minus 2y minus 5 equals 0. The line x minus 2y minus 1 equals to 0 intersects the circle at point Q, P, and Q. Find the coordinate. Okay, in here, we are given that they are intersection. So we can replace, in this case, it's easier to replace x. So 2y plus 1. So I can just replace x to the equation. So I have 2y plus 1 squared, yeah, as the x squared, plus y squared, plus 4, 2y plus 1, minus 2y, minus 5 equals to 0. And then I can expand this, 4y squared plus 4y plus 1, plus y squared plus 8y plus 4 minus 2y minus 5 equals to 0. And then I can simplify it into the quadratic equations. So it's 5y squared, 4y plus 12y minus 2 is 10y. And then 1 plus 4 minus 5 is equals to 0. So it's 0. We can cross this here. So this is the equation. This is the quadratic equation. So we can do the factorization. 5y, y plus 2 equals to 0. So we have y equals to 0 or y equals to negative 2. And then x, for x is, we can just replace to the easy one. I replace to here. So x is 1. And when y equals to negative 2, it's negative 4 plus 1, negative 3. So the coordinates are 1, 0, and negative 3, negative 2. That's it. Okay, I leave the others for your practice. Next is tangent to the circle. As we know that tangent is a line that touches the circle only in one point. It has a perpendicular to the radius. Yeah, it always perpendicular to the radius. So yeah, this is the key. So we can find the equation of the tangent by using these properties, the perpendicular lines. Yeah, if we can find the gradient of the radius and the gradient of the tangent line, so we can determine the equation of the tangent. So we will use this relationship, the gradient of the perpendicular lines. Okay, let's see example. Find the equation of the circle of the tangent to the circle x squared plus y squared minus 4x plus 6y minus 12 equals to 0 at the point 5 minus 7 on the circle. We know that the point is on the circle. So this is the circle, this is the coordinate, and this is the tangent. The coordinate is 5, negative 7. Now, to find the gradient of the radius, we need to know the center of the circle. Now, from this equation, so this is A, and this is B. So the center is negative 4 over negative 2 and 6 over negative 2. So the center is 2 and negative 3. So what is the gradient of the radius? This is the radius. So the gradient of the radius is right over 1. So delta y, negative 7 minus negative 3 over delta x, 5 minus 2. So equals to negative 4 over 3. This is the gradient of the radius. That means the gradient of the tangent, which is perpendicular to the radius, is negative 1 over minus 4 over 3 equals to 3 over 4. Now, we know that now the gradient is 3 over 4. And the line is passed through 0.5 comma negative 7. So the equation of the line is y equals to mx plus c. So y equals to 3 over 4x plus c. Find c by replacing the coordinates. So we will have negative 7 equals to 3 over 4 times 5 plus c. So negative 7 equals to 15 over 4 plus c. So it's, I make the denominator the same, negative 28 over 4 minus 15 over 4 equals to c. So c equals to negative 43 over 4. So the equation of the tangent is y equals to 3 over 4x minus 43 over 4. Or it can be simplified, multiplied all by 4. So for y equals to 3x minus 43. So 3x minus 4y minus 43 equals to 0. This is the answer. Number 2. Prove that the line is a tangent to the circle. Okay, we do the same thing. Find the center. The center is, this is A and this is B. So minus 8 over minus 2 and 4 over minus 2. So it's 4 comma negative 2. So if we draw, this is 4 negative 2, the center. And then this is a tangent. Okay, we don't know the equation of the tangent. We don't know the coordinates here. So we know that we don't have any other information from here. So now we will use the other method. So we cannot do this with this method. But now we can try to find the discriminant. Yeah, so I can just erase this. And then I can rearrange to x minus 3y minus 27 equals to 0. I want to replace the y. So 3y equals to 2x minus 27. So y equals to 2 over 3x minus 9. And then I can replace it into the equation. So it's x squared plus y squared, 2 over 3x minus 9. Oh, this one will be harder. So I just make it 2x minus 27 over 3. So I can just put it here, 2x minus 27 over 3 squared minus 8x plus 4y, 2x minus 27 over 3 plus 7 equals to 0. And then I rearrange x squared plus, so this is 1 over 9 for x squared minus 108 x plus 27 squared 729 minus 8x plus 4 over 3 2x minus 27 plus 7. And then to remove the fraction, I just multiply all by 9. Okay, I will write it here. So it's equals to 9x squared plus 4x squared minus 108x plus 709 minus 72x plus, okay, this is multiplied by 9, so multiplied by 12, yeah. So it's 12 times 2 is 24x minus 12 times 27 is 324 plus 7 times 9 is 63 equals to 0. Yeah, equals to 0. So we can simplify 13x squared minus 156x and then plus 468 equals to 0. Now we check the discriminant. The discriminant is b squared minus 4ac. So 156 negative 156 squared minus 4, 13, and then 468 equals to 0. So discriminant equals to 0 means one root or one intersection point. So this is a tangent. So this proves that the line 2x minus 3y minus 27 equals to 0 is the tangent to the circle. The last example. The tangent from the point P touches the circle at Q. Find the length PQ. Okay, we have to check, is P on the circle? Is it the same like the example number 1? Okay, how do we check? So replace the coordinates, 3 square, 0 square, 2 times 3 minus 4 times 0 plus 1 equals to 16. So this is greater than 0. So P is outside the circle. So this is coordinate, this is Q, and this is P. So P is 3, 0. Okay, yeah. Now find the center. The center of the circle is, this is A and B. So 2 over negative 2 and negative 4 over negative 2. So negative 1, 2. Okay. Now, we know the tangent is passing through P. So the equation of the tangent is mx plus c. That means we can have the gradient. Okay, we don't know the gradient of the radius or the gradient of the line. So we can use this. Okay, what can we find? Oh, we know this is a right angle triangle. And we can find the radius. The equation is radius square equals to a square. So this is square. So a square plus b square minus c. C is this one. So r square equals to 2 square. So r equals to 2. Now, find distance center and P. So center C and P. Distance CP is square root of delta x square. So 3 minus negative 1 square plus 0 minus 2 square. So equals to square root of 4 square plus 2 square equals to square root of 20. Now we know CP. CP, if you see the drawing, this is a right angle triangle. Right angle here. So this is root 20 and the radius is 2. So PQ is just a Pythagoras. The Pythagoras, so square root of 20 square minus 2 square equals to square root of 20 minus 4 equals to 4. So the length of PQ is equals to 4. This is the example for you also. Do it as your own practice. Okay, this is the end of this lecture. So thank you for watching and see you